This is Algebra 1, Homework 1-8, Literal Equations. Here we go. We're solving number 1 for a, which means we need to get a on its own side, everything else on the other side. So this 2 needs to be moved over. We're just going to subtract 2, meaning we have 2a equal to z minus 2. All right, now that a's are all on their own side, we need to isolate a by dividing by 2. We're going to go ahead and divide by 2. Divide by 2. You divide the entire side again by 2, and now a is by itself, and you're left with z minus 2 divided by 2. Any single time that I have a fraction, I need to be careful on the answer. I mean, this will give me full points, but on the answer key, sometimes they love to multiply the top and bottom by -1. If you multiply both the top and bottom by -1, then you could have a negative z plus 2 all over a -2. Either one of these two will give you the correct answer and full points on the test. I'm just curious what the answer key did on the back. So let's see, I have a z minus 2 over 2. Z minus 2 over 2 is, they did not multiply by -1 in that case. How about number 2? Number 2, we're trying to solve for x. We only have one x, and unfortunately, it's on the bottom of the fraction. So the very first thing I'm going to do is probably get rid of this negative, and then I'll probably flip the fraction. So let's get rid of the negative. I'm going to multiply the entire right side by -1. Multiply by -1 on the right, multiply by -1 on the left. When I do that, this, I'll do it in a different color, this -1 and that negative cancel out because a negative times a negative is a positive. And on the right side, now I'm left with y over 9 minus 12x. And on the left-hand side, I have a negative z. All right, so from here, what do I want to do? I want to flip the fraction. So let's go ahead and say I'm going to take the reciprocal of the right side, and that means I needed to take the reciprocal of the left side. But the left side doesn't have any fractions, so you need to assume that there was a fraction. If I take the reciprocal, it's going to be 1 over z. And on the right side, I now have a 9 minus 12x on the top, and on the bottom I have this y. All right, we're still trying to solve for x. We need to get rid of this 9, this -12, and this y. Let's go ahead and get rid of the fraction first. I always lean towards trying to undo fractions as first as possible. I did the negative first because I sometimes make mistakes with my negative. The order doesn't matter too much as long as you know what you're doing. I'm going to get rid of this divide by y by multiplying by y. If I multiply by y on the right, I need to multiply by y on the left. So these y's are going to cancel out, leaving me with a 9 minus 12x. That's a 2x. 9 minus 12x on the right. On the left side, this is really y over 1 times 1 over z. Y times 1 is y, and 1 times z is z. And I should have mentioned it in the last question that I was talking about z's, but please write your z's with bars on the inside of them so that I can distinguish between your z's and your 2's, because they look very similar without the bar in the z. All right, now we have a few more steps. I'm going to get rid of this 9 by subtracting 9. If I subtract 9 on the right, I need to subtract 9 on the left. 9 and 9 are gone, and this is going to be equal to a negative 12x on the right. And I have a y over z minus 9, which is a problem. I mean, normally I'm okay with this in my math class, but you should know how to combine like terms, or combine fractions at least. So this is a fraction 9 over 1, and this is a fraction something over z. To get common denominators, what we need to do is we need to multiply this 9 by z over z. If I do that, that will turn into, I'm going to run out of room here, so I'm going to move up to the top right. So let me come back up here. What I'm left with now is I have this original y over z. I can make my y slightly longer. And then this is going to be minus, and now it's going to be 9z over z. And that's still all going to be equal to a negative 12x. So notice now we have like denominators, and I can actually subtract. So when you add or subtract fractions, you keep the denominator. So I'm going to say that this is still something divided by z. And on the top, it is a y minus 9z. Okay, and on the right-hand side, I still have this negative 12x. Finally, it's time to get rid of this negative 12. I'm going to notice that this is a multiplication. Whenever there's no sign, you assume it's multiplication, and to undo multiplication, you do division. So I'm going to divide by negative 12. I'm going to divide by negative 12. And there's a cool little trick that I want to show you guys. While this is the correct way of writing out your rule, really what we're doing is we're just putting another 12 or a negative 12 on the bottom. What I can really do is put this negative 12 on the bottom, and you might say, that seems like it's just sorcery, magic. How are you sure that that works? Well, first of all, this negative 12 is gone, so I know I have x. On the left-hand side, what I really have is a y minus 9z, all divided by z. I'm going to keep it. I'm going to change this division into a multiplication, and I'm going to flip it. I normally have a negative 12. So I would normally write negative 12 over 1, but I'm going to flip it and make this a 1 over a negative 12. And you can see now very clearly that negative 12 and z are going to be multiplied on the bottom. And I'm going to have a y minus 9z on the top and a negative 12z on the bottom when I have my equation solved. And again, this is the correct answer, but on the answer key, they might have multiplied by a negative 1, multiplied by a negative 1, multiplied by a negative 1. The other answer that they might have on the back is a negative y plus 9z. Again, you're distributing this negative 1 into each of these. And the bottom could be a positive 12z. Both of these would give you full points on the quiz. Let me go ahead and box both of these. Both of them will give you full points. I'm curious which one they did on the back. Is it the y minus 9z? Ooh, we got the wrong answer. I'm checking it out. So notice that it's positive, positive, positive for number 2. We are on number 2. We should have all the same signs. So it should be positive, positive, positive. But in this case, we had a negative, which means we've made a mistake. Ooh, there's some extra credit out there. Let's see if we can find our mistake. We didn't rewrite the problem, so there's no mistake with rewriting the problem. We multiply by negative z. Oh, well, there it is. Where'd this negative go, Mr. Sandell? When you flipped it, this negative just disappeared. It was supposed to be there, so I need to add back my negative. I need to add back my negative. I had... and by the way, when you have a negative down here, you're allowed to switch the negative to whichever side you want. In this case, I have a negative on the bottom. I'm just going to flip it back to the top. It doesn't matter where the negative goes, as long as there's a negative somewhere. So I'm going to make it a negative y, which means that this is going to be a negative y, which means I have a negative y, which means I have a negative y, a negative y, a negative y, and therefore a positive y, and now I have the correct answer. Notice that the answer key on the back, they did multiply everything by a negative 1, so they have positives everywhere. You either have all negatives or all positives for this answer. In this case, you have all positives. I apologize for that mistake, but I'm human. I want to show you that humans do make mistakes, even if they're the math teacher. All right, number 3. We're solving for a. Notice I have an a right here. None of this stuff contains an a, which means you kind of ignore it. All we need to do is move this m over to get rid of this 2, and we're done. So I'm going to subtract an m, and that m is gone, leaving us with a 2a, and that's going to be equal to a b all over this 4n minus 2p minus m. And yet again, we need to combine our fractions. This is a fraction. This is technically a fraction, m over 1, right? So in order to subtract these fractions, I need to have the like denominator. I need to have this denominator and this denominator be the same. What we're missing is this denominator needs to be multiplied by this 4n minus 2p, and this denominator needs to be multiplied by 1, I guess. You don't really need to multiply by 1 because that's the same thing as this by itself. So I'm just going to multiply both the top and bottom by 4n minus 2p, 4n minus 2p. And that's going to leave us with the following. It's going to be equal to, I still have a 2a on the left. I have b on the top. I have a 4n minus 2b. Nothing has changed. Here's the change. This m is going to be distributed into these two terms, and I'm going to have, technically it's a negative m that's being distributed into those two terms. So I'm going to be careful with my signs. I have a negative 4mn. I usually go with the alphabet in terms of the order. And then this is going to be plus, because a negative times a negative is a positive. So plus, you always do the number out front, the coefficient out front, and then mp. And then this is all going to be divided by 4n minus 2p, again, because 1 times 4n minus 2p is 4n minus 2p. All right, and I'm still leaving the left side alone. It's still 2a over here on the left. But now this right side is going to be b minus 4mn plus 2mp, and this is all over 4n minus 2p because they are like denominators, so you keep the denominator the same, and then you just kind of squish all this stuff up on the top. All right, and finally, we're going to get rid of this 2. The way that we do that is we divide by 2. So if I divide by 2 and divide by 2, then I'm going to get this following equation where a is equal to, and again, I'm going to use that same trick where if I'm putting a 2 on the bottom, it's really just putting this 2 on the bottom down here. And you do have to distribute, be careful. So I'm going to distribute the 2 into both the 4n and the 2p. The top is going to stay the same. This top is still b minus 4mn plus 2mp. All of this is divided by 2 times 4n is 8n 2 times negative 2p is negative 4p. And again, that is one of the two answers. Another answer is to multiply the top and bottom by negative 1. The other answer is a negative b, you just change all the signs, right? Plus 4mn instead of minus 4mn, minus 2mp instead of plus 2mp, and this is all divided by negative 8n plus 4p. And I ran out of room there. I think if I just move all of this stuff over a little bit, it looks a little bit better. Here, let me make this look a little bit neater. This is going to be plus 4p. Both of these would be correct answers. So let me box. This is a correct answer. Let me not get rid of 6. And this is also an answer. I wonder which one the answer key chose. Did they do a positive b on the top or a negative b on the top? They did a positive b on the top. So I'm going to look at my positive b on the top, which is this equation. So I have a negative 4mn and a plus 2mp. Negative 4mn plus 2mp, I got that all correct. And then on the bottom I should have a positive 8n minus 4p, a positive 8n and a minus 4p, oh wait, sorry, positive 8n and minus 4p. Okay, that was correct. I was worried for a sec that I was doing something backwards, but we did get it right. All right, so number 4, 5, and 6 are all tricky because they have multiple of the variable that we're trying to solve for. Like I have an x here and an x here. In all the last scenarios, I had just one a. I had just one x, or sorry, there's the one x. I had just one a. This is a case where I have multiple of the same letter, so there's an extra trick involved in these problems. And I'll show it to you right now. So the first thing is make sure that all of the variable that we're trying to solve for are on their own side. So I have a mixture of an x and a negative 4. So that's kind of a mixture of variables. I don't like that. Notice that the right side just has an x and a z. And this term is kind of stuck. Let's move this x to the right side, and then we're going to only have x's on the right side, mixed with a little other stuff. But like this negative 4 doesn't need to be over there. So I'm going to add 2x as my first step. Add 2x. Add 2x. While you might think that, yes, this is a like term, this is a like term because it's zx or it's 2x. It's something x. Because we can't add their coefficients, I don't know what z plus 2 is. We're going to leave it and just deal with it later. But first and foremost, the negative 2x and 2x are gone, leaving us with negative 4 is equal to, I should write this as xz plus 2x. From here, I need to get 1x. I'm going to turn 2 x's into 1x using what's called factoring. So what I'm going to do is I'm going to factor out an x. And it's essentially asking this question, if I divide each of these terms by x, what is left over? Well, x divided by x leaves us with just a z, and 2x divided by x leaves us with just a plus 2. And then I still have this negative 4 on the left-hand side. Notice that I have turned 2 x's into 1x. And now this is saying x times something. So if I'm doing x times something and I want to undo times by something, I'm going to divide by that something, and I'm going to divide by that z plus 2. If I do it on the right, I also do it to the left. This is z plus 2 also divided on the left. And these will cancel each other out, leaving you with your x isolated, and it's negative 4 all over z plus 2. As a reminder, whenever you have a fraction, you can multiply both the numerator and denominator by a negative 1, not just a 1, but a negative 1. You can multiply by negative 1, meaning that you could also have a positive 4 and a negative z and a negative 2. You can just switch all the signs. That's what I really mean by multiply by negative 1, is switch all the signs, and that is also correct. So this one I can box, that is correct. This black one is boxed. Both are correct. You don't have to do both. I'm doing both to show you that you can get both. Just do one and notice on the answer key that you're still getting the right answer. You just have to flip all the signs. So number 4 is the numerator a positive or negative? Okay, so number 4, the numerator is positive, which means they did flip the signs. So they have positive 4. They should have a negative z and a negative 2 on the bottom, a negative z and a negative 2 on the bottom. All right, we got it right. Let's do, and by the way, I'm doing a bad job of showing this, but you should be proving that you're checking your work. That is the, let me choose a bigger highlighter. This is the correct one. This was the correct one that we saw. Which one was correct for number 2? Was it the negative y? It was a positive y on the top. So number 2, this was the correct one. And for number 1, was it a z minus 2 on the top? It was a z minus 2 on the top. This was the correct one for number 1. You should be highlighting the correct answer in each of your problems. All right, time for a little bit of a trickier one, 5 and 6. 6 is kind of gnarly. Number 5, the first thing that I always look for is, can I get rid of a fraction? If there was a negative out front, I probably would have gotten rid of that first. But I have a 6 on the bottom. Let's go ahead and get rid of that. The way that we get rid of that is to multiply by 6. Multiply by 6 on both sides. 6 and 6 will cross cancel, leaving you with 6 times 3ux, which is an 18 ux, and on the right side I have a 4x plus 5y. So from here, I need to make sure that all my x terms are on one side. Notice I have an x term there and an x term there. They're on different sides. Let's move this 4x term over here to the left side by subtracting 4x. Subtract 4x, subtract 4x, and that leaves us with a negative 4x plus 18, that's an 8, plus 18 ux, and that's going to be equal to a 5y. Those crossed off. All right, I have all my x terms on the right, but the problem is I have 2 of these x terms. In order to turn 2 into 1, you're going to factor. I'm going to factor out the x to turn that into 1. What is left over? We'll divide each of these by x, and we will find out. X divided by x, or negative 4x divided by x is a negative 4. And an 18ux, again, x and x cancel out, leaves you with a plus 18u. The right side stays the same, it's still a 5y. And notice again that this is going to be an x times some stuff. The opposite of timesing by some stuff is to divide by some stuff. So I'm going to divide by that negative 4 plus 18u. And if I do it to the left, I also do it to the right. This is dividing by negative 4 plus 18u. And these terms will cancel each other out, leaving x is equal to a 5y divided by a negative 4 plus 18u. Again, this is a correct answer, and you can just leave it like this, but I want to see what happens if I multiply both the bottom and the top by a negative 1 to see another possible answer. You could also have a negative 5y on the top. You could also have a positive 4 minus 18u on the bottom. Both of these are correct. I'm going to box both of them, and I'm going to see which one the answer key chose. In number 5, the answer key chose a positive 5y on the top. So let's check. There was a positive 5y, and I should have a negative 4 and a plus 18u. A negative 4 and a positive 18u. That is indeed correct. So I'm going to go ahead and highlight that answer. So this was the correct answer right here. All right, and then we move on to our last problem for the homework. And we are solving this problem for A. Notice I have an A here and an A here. We need to get all the A's on the same side. It doesn't really matter which side I choose. Let's just choose the right side. So I'm going to get rid of this A and move it to the right side by subtracting A. Subtracting A, which means I have this BA minus A on the right side of my equal to sign. But notice there's all of this stuff that doesn't have an A in it. You guys, both of you, need to move to the left because you don't have the variable that we're looking for. And we're going to subtract a 4n and add a 1 to get rid of each of those, right? So that'll cross and cross. But if I do it to the right, I also do it to the left. I need a minus 4n and plus 1 on the left. So on the left-hand side, this A cancels out. I'm left with a 3m minus 4n plus 1. And that is going to be all equal to BA minus A, which we can move over here to the left. All right, so we got all of our A terms on one side, all the non-A terms on the other. That's kind of the first step. We don't have any fractions to undo. That would have been probably the first step. And then from here, I need to turn 2 A's into 1 A. And the way that we do that is by factoring. We say we factor out that A, and that means that I'm dividing each of these terms by A. So BA divided by A, the A's go away, and this is left with B. And then here's the harder trick. So yes, you copy down the sign, negative turns into a negative, but what is left over when A is divided by A? A lot of students will say, nothing, and you'll put maybe a 0, or you'll just leave it blank and you don't know what to do with this sign. Well, here's the answer. A divided by A is the same thing as 7 divided by 7 or 3 divided by 3. A divided by A is 1. So I'm going to say B minus 1 in this case. And just to do a sanity check, if I were to go backwards instead of going forwards, I'm going to go backwards, and the way that we do that is by distributing. If I do A times B, I get BA. If I do A times negative 1, I get a negative A, so that seems to work. Let me rewrite the rest of this equation. I still have this 3m minus 4n plus 1 on the left-hand side. And again, I'm trying to solve for A. Right now, A is being multiplied by some stuff. The opposite of multiply by some stuff is to divide by some stuff. So in this case, I'm going to divide by b minus 1. If I divide by b minus 1 on the right, I divide by b minus 1 on the left. b minus 1 cancels out, and I'm left with a by itself. On the left-hand side, I'm going to rewrite all this stuff again. 3m minus 4n plus 1, all divided by b minus 1. Again, we have a fraction. This is the 6th time out of 6 that we have a fraction, which means I can multiply the numerator and the denominator by a negative 1, which is a fancy way of saying switch all the signs, and that will give you a new and correct equation. Negative 3m plus 4n minus 1, all divided by negative b plus 1. I switched all the signs. This is a correct answer, and this is a correct answer. I wonder which one the answer key chose. Do they have a b minus 1 in the bottom, or do they have a negative b plus 1? They put a negative b and a plus 1 in the bottom, so I'm going to be checking this one right here. Let's check. Do I have a negative 3m, a plus 4n, and a negative 1? Negative 3m plus 4n and minus 1. I got it all right. So I'm going to go ahead and highlight that one. I got it all right. That's the one that they decided to use. And that concludes homework 1-8. Thank you for watching.